Good afternoon, everyone. This is Ty Tomasi, Director of Accessibility, Belonging, Inclusion, Diversity, and Equity here at APH, and we are here for another week of an in-depth look at programming languages with Florian Beijers, and I'm going to introduce him to take it away. Thanks again to our sponsor, CDW, for their generous support of our classes.
Excuse me. Good start of the day today, people. Hello. I've just shared my screen. I hope it's not looking quite as blah as it did before. If it does, there's not a huge lot I can do about it.
Florian, it's showing on screen, but there is still this central space. It's right in the middle of a screen that is blacked out. And now it's more blacked out than grayed out.
Okay, that is special. Yeah, I'm gonna reset this.
Just bear with us till we get these technical difficulties ironed out.
Yeah,
Make sure we get the screen working.
It's been this all day. I don't know.
Numbers. What's even happening? Manage toolbar. Accounts menu. Main landmark. Tab control. Numbers. Button. Editor actions toolbar. Section. See users. Florian.
I wonder if it's just the dark theme.
Search files by name. TATE. No matching results 1 to 1. The name of a TCME developer. Generate color theme from preferences. Color theme. Control plus references. File icon theme preference. Quick input list. Dark plus. Default dark 8 of 16. Kimby dark 9 of 16. Dark. Visual abyss 6.
As you're changing the colors, I can see your menu, but it's that blackness, the blacked out area is still floating above everything you do on screen.
Notification from Discord.
What is doing that?
Modify green. Numbers. Number in Python. Number in Python. Dash. Dash. Number in Python.
I'm looking.
Main app with num test. No containing object. Recognizing result. Bullet num. Screen sharing. Bullet stop share. Oh.
There is no text or anything of this, right? It's just like blocking everything off.
Just total black.
3, 4, 5, 6, 7.
Underneath it, I can see the list you're trying to display, the 1, 2, 3, 4 down the side, but that's all I can make out at this time.
From Google Drive. Ours. It. Yes.
That is special. So yeah, I wanted to start with this anyway. I've been a little bit absent on the Discord like of this week because my computer decided to completely disappear on me. So I had to like do a whole lot of rebuilding. What I'm going to do is restart the thing in the meantime. And that made it a lot more difficult to keep up with all the things, like all the Discord. There's been some really cool ideas in the Discord over the last couple of days. Study groups have been mentioned, clubhouse rooms have been mentioned, which is also great. Also some Discord questions that came up. I'm going to cover some of those today. I wanted to do a quick, really quick Discord tutorial for those who just aren't very familiar with these kinds of programs. Because you're going to see a lot of them, like Electron.js, like we saw the other session a couple of weeks ago, is everywhere. Like even VS Code uses it. And it is helpful to know sort of how to deal with these things as you go, because like essentially it remembers it really behooves to sort of know how these things are supposed to sort of work in the sense that you have your screen reader that does several things. It'll switch modes on you. It'll have to like learn what the interaction patterns generally are, and knowing how all that works is super helpful. I think I may know what's going on, actually. Discord, for example, has really 2 ways you can interact with it properly. There is essentially the browse mode, which in NVDA is browse mode, and DAWs is virtual cursor. In all the other things, it's called different things. Like VoiceOver doesn't really have a separate cursor per se. It uses its own thing that is essentially sort of a hybrid between the 2. And then you can use either the regular click or the mouse click. I'm also seeing that my Zoom notifications are coming through. That is not helpful.
Florian, there was there's a comment from Deborah in the chat that says perhaps his shared screen is blank because he checked optimize for a video clip. When I share a screen, it makes my screen invisible to Zoom viewers.
That is interesting. Oh, actually, generally what that does, or what that's supposed to do, is move away the video thumbnails, so you don't see like the other people in the Zoom call. I'll be happy to try it though. Like if that's the problem, I don't think I even turned that on the second time, but I shall try. Sorry, bear with me while I fix this out. The audio is on. Video clip is actually was already off, so that's not it. But yeah, we'll try this one more time. Here we go.
Yeah, it's still exactly the same. I can see you scroll down the side. It appears there's like a small version of what you are trying to enlarge on the screen on the far right side of what is being displayed. But yeah, it's the same two blacked out areas right dead center on the display.
I'm really quickly looking through my everything, see if I can see why that might be happening. I don't immediately do. Obviously, we can't really spend the entire time fixing this, so I will try to do the best I can. And if I think of something, I will obviously fix it. But as of right now, I have no idea why it's doing this. Actually, there's one thing I could try. Maybe just not use VS Code and use something else. Maybe it's VS Code thing. If it is a VS Code thing, that would be a solution. Not a very good one, but it'll work. I need to really quickly switch editors then, doing that now. What I was saying about Discord is essentially you have the two modes. You have the browse mode and you have the virtual mode or browse, or the focus mode rather, or virtual focus off. And it actually sometimes really matters if those are on or off, because more and more things that are actually used a lot, for example, VS Code or Discord or other things, Skype even, like they kind of want you to use their own hotkeys for things. And using, for example, Discord is in some respects easier if you do that. For example, if you tab, if you shift tab away from the edit field for text, where you can type your messages, you'll get into a list of messages. If you do like twice, you get to a list of messages that you can arrow through, up and down through. That way you don't have to deal with like the headings, all the other things. It'll just read you the entire message all at once. And if you then use your applications key or your Shift F10, there's various options you can do on that particular message in particular. For example, respond to it or add a reaction to it. It's essentially an emoji that shows up near the message. And then you can essentially acknowledge that you've seen the message and say something about it without actually having to type. And you can do all that with the applications key. So it really helps to do that. It may not always work right when you're in browse mode though, because at that point you're more selecting a piece of text that NVDA is giving you rather than the actual element on the screen, which is why that may sometimes break. I am in the meantime trying to show another screen. I hope this works. This is when someone tells me if it worked.
Yes. The screen, your editor, you feel your box is larger and clearer, but it still has those same sections blacked out.
That is very special. I don't know what to tell you. It's not something I have seen happen before. If anyone has suggestions, I'll happily take them. But at this point, I have no idea why that's happening.
My guess is it's that it's a video driver, possibly, since you said you had to rebuild your system, because it's something with the display, I guess, because there's something hovering there. I just don't have an explanation for what it is.
But what? Like, I just did something. I don't think.
Part of the screen actually grayed out when you did that, and now it came back. Now the whole screen grayed out behind the black boxes, that the black boxes still are floating above the grayed out display now.
This is special. Yeah, it does sound like it's some kind of Zoom or video card issue. What do you guys want to do? Do you want me to just do it without visuals, or the best I can, or what is smart here?
If the audience doesn't require any visuals, then I feel like that's probably the best move forward.
Yeah.
You have some hand raised.
You see, I'll be talking and I'll be showing the audio that's happening, but like I'll mostly be lecturing today anyway, so it's mostly be me talking. Like there will be a little bit of demoing, but it's mostly going to be the screen readers. So Yeah, I'll need to get this resolved. And well, until I do, I guess this is the only thing we can really do. Sorry about this. This is not something I have really control over. In that sense, I will share my audio at least so you can hear my screen reader when I'm in that window. Here we go. Turn the sound on. Oh, it's already sharing that. Okay, well, I didn't know it was smart about that. Cool. This should be audible.
Speech mode talk. Numbers live.
Yes, we can hear your.
Perfect. Fantastic. Okay.
Numbers
There we
participants number in Python as also shown in our
Can
previous
you
Python
still
script.
hear
Note
it,
that our
or
number
is
in
it
case
gone
one.
now?
Number first.
You can still hear it.
For now, we will set
Okay, perfect. Well, this was a bit of a hiccup, but we'll deal with it. Essentially, there's a couple things we do here. This is essentially what I've opened is the annotated version of the thing we did last week. And some of you did the homework. I've seen some of your homework. I've commented on some of your homework. I'm aware that some of them haven't had feedback yet. I will get to that as soon as I possibly can. Like I said, it's been hell this week, but we will certainly look into that as soon as possible. Now, what I did see is that some of you found the first exercise in particular worked well.
Everyone. No problem, Trevor.
I'm going to turn off the speech for a
off.
sec because I apparently have Zoom on. I'll fix that in a minute. Oh my God. Some of you found the way to do the random number between 1 and a set number. You did that with an import of the random module. Very good. That is the way to do that. So essentially, you would import random at the top of your script. And then you would do random.randint for a random integer, and then you put the lower bound and the higher bound the number should be between, and then it does it. It'll essentially give you a number. So at that point, you made the game more dynamic. It's no longer just a number 20 now. And that is cool. Obviously, the next thing you would have to do at that point is to make sure that the game doesn't end when you do one guess, because, well, if you do that, then you're never going to, like, it's going to be a very small chance that you'll actually guess the number unless you have like a really small bounded box, as it were, between two numbers. Say if you do the numbers between 1 and 5, you can get away with just having one guess, but you'll quickly find that you need to essentially loop to make sure that you check more than once to see if the guess is right. So you essentially make a game out of it. You do it once, you have like one guess, and then afterwards you're like, okay, well, that wasn't the right guess. Maybe try again. So at that point, you would need another variable, for example, has guessed, some people I've seen use, or some other name that indicates, well, it's not been guessed yet, but it will be guessed at some point, maybe. So we'll just check for that. Now, once you've done that, you can loop on that thing. So while has guessed is false, so while it has guessed is not flipped to true, you just keep running the same code over and over and over, essentially saying while X is true, keep this up, and when it flips, stop doing it and essentially end the program. Now, you can do that while something is true or while something is false. It doesn't really matter. It depends on what you called your thing. Like, you could also call this is not guessed, and then it would be while is not guessed is true. And then you would have to wait for that to flip to false before you end the game. So those two sort of went hand in hand. And the idea of that exercise was mostly for you to realize that, like, okay, now the game is boring, and because we never beat the actual game because like only one guess is just too small of a chance. The second one was harder, and it was intentionally a little bit over the level that we've currently covered, because really the easiest way to deal with this is with what's called an exception handler, which essentially says, if an error happens, do something so the entire program doesn't just crash, but like gracefully recovers. And some of you found this. Some of you probably Googled on how to do this, and then essentially found that you can do it. Try, and then do the input conversion, and then if the input conversion worked, you can just keep going, and if it didn't work, you essentially just give them a message that says, hey, you're supposed to enter a number, and then that fixes it. So that's good. I also saw some people essentially use isNumeric, which essentially has you only convert the number if the number is numeric. That works too. That's another way to do it. It's a very interesting way to do it. Certainly not wrong and very creative. I commend whoever did that for thinking of it. Now, what we can do this week is essentially look at how we can make this code look a little nicer and a little more future-proof. And there's a couple things we need to cover for that. Primarily, it's going to be about making what we did into functions, as well as maybe looking into adding some extra things. I was going to add a sound effect, for example, for when you finish the game. I honestly don't even know if I have Python working at the moment, so I'm not sure if I'll be able to do that this week. That might be something we do next week. But what I will do is look at some refactorings. So to refactor essentially means take a bit of code that already works, or maybe code that doesn't work, and then just make it work better or look nicer or just easier to read. A lot of code becomes very unreadable as you keep going. Just add more things to it, and it just becomes this big, what's referred to as spaghetti code, where everything is tied to everything, but nobody knows where everything's coming from and where things diverge and converge. So keeping your code readable is an art form in and of itself, and sometimes it can be really tricky to do. What can really help you in that sense is your algorithm. So if we look at the top of that annotated file, it says in Python is preface, it's a comment, and then we have our algorithm. So what it says is, first we need to make Python think of a number. For now, we will set a number ourselves to make sure it's always the same. This is a technique known as hard coding a number. Next, we need to greet the user and ask them for their guess. So these are what's known as atomic units. They're very things that do one thing and do them well. And there's not really an easy way to make this even better. What you could do, for example, is wrap these in, for example, a start game function, and then just have that be the start game, where it just thinks of a number, and then it thinks of a number, and then it shows the welcome message. That could be the game startup function, because you're always going to want to do that only when the game starts. I'm going to go through these functions real quick, and then I'm going to open the floor for questions. We're almost done. So we check the number, we check the function, we check the user's guess against the number we stored. And then we handle what happens when that number is either too low or too high or exactly right. Now, these you could make into two functions. You could have a check guess function, and you could have a report response function, for example. And what you'll find is that when you do that, and you essentially put all these calls in sequence at the top of your file, you get something called, something along the lines of startup, check guess, report result, and then essentially repeat. So at that point, you've made your, it's very clear from looking at the top of your code file what this code is supposed to do, what order the functions go in, and then if you need to look at a particular function more specifically, more detailedly, you can just go down to just that function and have a look at just that bit of code, because the other stuff technically shouldn't matter to you at that point, because you're only interested in what this particular function does. And you'll find that once you work as a developer, or you have to do something on a project that you want to volunteer for or whatever, this is a pretty common thing to do, because at this point, it becomes really easy to figure out where, for example, a bug might be coming from. Oh, the bug is happening when something gets reported to the user. So there is really only two places that can come from, either from the calling function, which in our case would probably be check guess, and then, or it's coming straight from the reporting function itself. So it narrows your, what should I be looking at, significantly, and it makes it a lot easier to find things and find problems. So yeah, that is how we could compartmentalize this essentially into several functions. I will show you how to do that for one particular part of this code in just a moment. But we have covered quite a few things last week. We also covered quite a few things just now, but like maybe people aren't quite clear on what functions are anymore or other things of that nature. I would like to open the floor for questions at this time, so I can like get some people like questions answered before we just pull those on forward.
Florian, early on when we first started, Peter had asked a question in the chat about the vocabulary. He said you gave commands for viewing output and returning to your file program. Could you please repeat them so I can write them down? I should have done that last week. Or is there
sorry, can you repeat his message?
Yeah, it says last week you gave commands for viewing output and returning to your program file. Would you please repeat them so I can write them down?
Oh, yeah. So what you do is essentially, and this is also in the, if it helps you to remember, this is also in the notes for last week's lecture, I'm pretty sure. But essentially what you do is you have your command line window open. So you do Windows R for your run dialog, you type CMD, you press enter. At that point, you need to navigate your command line to where the file you're working on is. That'll be something you'll have to get from your Visual Studio Code or the other editor you're using. You do that by, for example, if you know where you saved it, you can use, for say you have saved it in your user folder and then in a folder called code, you would do CD space code to go to that code folder. You will see that it worked because the code will be at the end of your prompt, which is the line that comes up every time you do a command at the bottom. And at that point, once everything is installed correctly, what you can just do is Python space your file name and then press enter. So your file name is the argument for the Python command at that point, and it should run your code. So at that point, you can get into a flow of running your code, checking the output, seeing if it's what you wanted, what you expected, and then you just go back and do it again, change your code, and then just repeat. You can repeat your last command you type by just pressing up arrow and enter, because it'll go into your command history. That's also why you can't just up arrow to see your output. You'd have to use the JAWS cursor or the NVDA flat review commands for that. I hope that clears it up a bit.
The first person that had their hand raised, I'll activate. Her name's Pamela. Pamela, you can go ahead and unmute.
Yeah, go for it.
No, thank you. I tried to lower my hand, but I have no questions. Thank you.
You have no questions, okay?
Okay.
Sorry, I have no questions.
Okay.
All right, you're all good.
The next one up would be Deborah.
Good morning. I think something that might be good to explain is why some function calls have a left paren and a right paren around them, and some of them are preceded by a dot.
That'll come up at some point. Like that's going into object-oriented programming, which I will certainly cover, but not quite yet. They will, either way, they will have parentheses around them. As in, like parameters for a function always do. It's just like it depends on where the call is going to, if you're calling it on an object or just a built-in. But yeah, that's a good thing. And I will mention that once we get to it.
And I've also noticed I had a little trouble with str, and int requires 2 parameters. So that was a little confusing. I finally figured it out. So you have to you can't just say int name of my string in parentheses. You have to give that second parameter. And I did have also a few issues with str, trying to convert an int back to a string.
Are you on Python 2 by any chance?
No, it's 3.1.0.4, the latest thing.
Interesting, because I literally had I did this int function the other week, last week in class, and it didn't give me that problem. So it might be a very recent development. Do I even have Python?
Doesn't matter. I figured it out anyway. Thank you.
Yeah,
I'll go
no,
back on mute.
it's fine because the the second parameter for the int is only the base, which you really shouldn't need. So I would have to look into why it's doing that for you, but I'll look into that and let you know, because that shouldn't be happening. Even if I go down the list here and I check the annotated example that we used, there is a response equals int response there, which works fine, and it actually worked fine last week in class. So I'm not sure what you're seeing there, but I'll look into it. Anyone else?
There was one more hand held. It's Alan. You can go ahead and unmute.
Yeah,
Go ahead.
this may be a bit redundant based on what Deborah just said, but so on that response, the line that started with response, where we're getting the input for response, could we have put the integer function in front of response and then closed off the paren for that, so that we would have made the response an integer? I'm assuming that's valid, but then the next command where where you display or you print, you input and you've got the string and then you've got a concatenation plus sign and then followed by response. If we had made response an integer, will that work, or do you have to convert response back to a string to be able to include it in a print output?
Good question. Actually, that would not have worked, but what you could do is make the response be the second parameter instead of within the same string. And I think it then auto converts it to string. So yes, you could do that, but you'd have to change the code slightly. And as for, could we not just wrap the int around the input call? Yes, you could. This question came up last week as well, and I didn't do that for the reasons that it is a little bit harder to read for people who aren't quite sure what they're looking at. But yes, you could totally wrap the input call into an int.
Right. I still have a little bit of vision, but I understand exactly what you're saying. Yeah, it is. And of course, I Googled it to see how they presented it, and that's the way they did it then. So
yeah, it is. If I were to work on an actual code base, that's probably what I would do as well. I just made it into 2 lines to make it a bit more explicit what's happening.
So we could, if I followed what you said, we could say, we could have a print line that said print, this is what you entered, or and then we could go to another line and just say print and then the variable response, and then it would put it on 2 lines.
That would give you a new line. Yeah, what you could also do is just print quote string quote comma and then your response, and at that point it should also convert it to string and just add it to the end of it.
Oh, I got you. Okay, all right.
That's apparently also something you can do. So yeah, that's one other way you can do it. There's a lot of ways to skin a cat, if that makes sense.
No, exactly right. Yeah, I understand. Thank you so much.
Not a problem.
Florian, there was one final question that came in the chat. It says, it's from Manny. It says, is it necessary to define a function like start game when it is going to be called only once?
That would depend on what you're going to do with it. And I'm going to actually continue into that next. So that's a really good segue. Thanks for that one. Appreciate my viewers helping me here. Because I think that's the final question, right?
Yes.
Okay, so there is a couple reasons why we refactor. So for example, excuse me, what I said before, readability is certainly one of them, and making it easier to essentially narrow down the scope of what you're trying to look at and what you're trying to fix is another one. There is another reason why you might want to do that, and it's actually quite interesting. We haven't really done this yet, but we may cover it next week in our final session for the moment. What is interesting is when you have a function, you can call that function. And that function can be called from anywhere. So for example, if you were to want to make this guess the number game into a web application, then rather than rebuilding the entire thing, you can actually use some of the code that we've used here and use it in that web application. You could, for example, if you were to make that check guess function, for example, you could have that be hanging out in a module somewhere and then import it. And then once you have it imported in, for example, something like Flask, all you'd really have to do is make a couple of little changes to make sure that it works well with that particular module, and then you have your check guess function already written for that particular purpose. So that helps in the sense that you then don't have to redo your stuff. You often see in the wild right now, if you look at developer jobs, there's a lot of different things that are so-called cross-platform, and they are write once, run anywhere, which was a big thing about Java back in the 90s. And they use a very similar system where essentially you write it once, and then you just slap a new UI on top of it, and then you just call the functions you've already written in a new way, and off you go. You have a new application for a new system. And in that scenario, you probably don't need a start game function because it would be different. You'd have to like start the web page, for example, and have a button that makes the game start, or it probably even starts when the page loads. But you would pretty still want to do the other ones where you essentially have a report and a check guess, and then the report to user could just return, for example, a string that you can then show in your web page and make look nice. So in that sense, it really depends on what you want to do with your code, and that makes this really fun. Because at that point, programming sort of becomes an art form as well as a science, where you're like, okay, do I want this? Do I need this going forward? Is this going to be something I'm going to be using in another project anytime soon? Things like that, which are essentially things you would have to like defend against. For example, if you're in a actual job, you'd have to defend your choices and why you did this to your colleagues. Like, hey, why is this not doing X, Y, Z? Because it would make it more cross-platform, or it would make it more applicable for different projects, which is usually what software, developer companies want, because at that point you write it once, and then if some client down the line needs this functionality again, you can just show it off again. And then at that point, you already have half the work done. And if you do that very, very often, and you just find the same problems you need to solve every single time, this is when, for example, Python packages start existing, where someone has realized that this is a thing that happens a lot and needs to be essentially pre-built, like a Lego brick that you can just pick off the ground and stick anywhere you need it. And if then a whole bunch of packages come together to essentially work towards a common goal, that's when you get a framework. So if you look at Django, at Python, there's a couple of these frameworks. There is Django, which is a what they call batteries included web framework. Essentially, it lets you build web applications all the way from like 0 to think the new Facebook, for example. And that is, for example, one way how we can bring the HTML and ARIA that we covered in previous sessions together with the Python we're covering now. So yeah, at that point, would you want to start game function? No, probably not, because the start game function will probably be different. But all the other ones, the actual logic of the game can be reused and should be reused if you're going to make another version of the game. You could make one for the web. You could make one that, for example, Alexa can use. Oops, I hope it didn't trigger anyone's smart speaker there, sorry. You could use, maybe you want a VR version of Guess the Number. I wouldn't know why, but hey, if that's something you want to do, you could use this logic again. All that changes is the medium you're showing the exact same data to. So in that sense, that is another reason why we do these kinds of things, why we have this stuff. In the meantime, I've gotten Python to work, so that's nice. I have the exact same version as Deborah has, so I'm actually going to really quickly check if that's a regression. I'm going to make a string. I'm going to type string equals hello. String equals hello. Now string is hello. If I print out string, I'm not entirely sure if you can hear that, but it's saying hello back when I ask for the value of string. Now, if I want to make this into a string, it's going to fail. Into an int, it's going to likely fail, because this is not an actual convertible thing you can just stick a word into. So I'm going to stick the word string in there. And we get a trace back. And what it's giving you as a response is that it's an invalid literal for base 10, which is probably what you would have seen if you tried to do the second exercise that I set for last week's homework. Now, if I set string to a number, I'm going to do that now by just putting the number 53 in there. Oh, string 53 in quotes with an equal signs in the middle, so it assigns it. And I try this again. It works. So like I said, I'm not sure what happened there. I'd have to see your code that you were using before. But this does appear to work. So therefore, something may have gone screwy with your libraries. I will, yeah, ping me on Discord. I know you're on there, so you can find me there, and we'll look into it together and why that broke. But yeah, the syntax for int should just be one argument as well as str. I'm not listening to that right now. We'll cover that in just a moment when we have time for questions. I will also see if I can really quickly figure out how to make sure that doesn't keep happening. The thing we were doing, we've essentially like divided up our code into distinct portions, and we could stick those into functions, like I said. Functions, we have seen a couple at work already, like ones that were built in. We haven't made our own yet. And that is a problem, because at that point you would want it to be properly wrapped into things, and functions essentially communicate through arguments and return values, like we've seen before. If you take the input for a user, the argument is the string that shows to the screen, and the return value is the thing that a user types back. And that's actually essentially how our homemade functions would work too. Now, we've also seen that they don't necessarily need both of those things. Sometimes they don't. Sometimes they really just need one of the two, or not even at all. If we look, for example, at the print, print doesn't return anything. Print really just shows text on the screen, but we are not interested in what it returns because it's not necessary. The way that print works is that it gives you an effect rather than a return value, and we call those side effects. Essentially, the side effect of running the print function is that you see lines of text appear. Now, in the case of the print function, that's actually good because that's what it needs to do. But when we look at it like from a functional point of view, where function actually matters to be part of a chain of functions, as it were, we get, there we go. We get, lost my train of thought. If we get a chain of functions, we don't get anything back from the caller or from the callee when like return value, for example, is missing. And at that point, it's generally something you don't want to use in, say, a chain of functions where something calls something else, which in turn calls something else. These are just things that you do while other things are happening. And that's another reason why we call them side effects. Now, how you would do that, how you would do such a thing is actually pretty interesting, because when we start refactoring our code, we need to look at where would be good things, what would be good things to refactor. So right now I'm in the middle of the code. I'm going to scroll down just a little bit.
If print here guess is tool, if response less right guess number in the event that there is response blank. Print you entered plus response number. Here we have a debug statement, a line of code that is purely here for us, the programmers, to make sure user input is handled correctly. We are adding the text to user type to the entered string and then printing it to the screen. Blank.
So at this point, this isn't really all that useful.
Response equals int. Response number. We are about to compare the number the user
we
entered.
have we have converted our response here,
If
and now here we're doing an actual check. It says if response is less than right guess, and then a comment that says in the event that the response the user entered is lower than the value. This is where our checking code begins. So this would be a prime specimen for turning into an actual function. that we could do. And to do that, we need to first isolate where this bit begins and where it ends, and if it has any dependencies. So if we look at these if statements, it says that it needs response and it needs right guess because it's comparing those two things.
Print your guess is too low.
Now,
Number tell the user. Elf response greater right guess. Number print your guess else. Number print you got it. Print you got it. Number tell the user. Print you got it. Number tell the user.
That is all this does currently, and we can get by with using these lines into a function. Now, right response
print you got it. Number tell the user.
And right guess and response are both necessary for these functions to work. Now, let's just for the moment assume that these two things are in different files or in different scopes, and the variables that we have here up top.
Number in Python, and also number for land. Right guess equals 20. Number store the number 20 in the
This one, for example, the right guess one. Let's say we don't have access to those in the file we're in, because that happens pretty often. What we would need to do first is to make it like a lot easier to read for us as well, and to just not get your lines confused, is to make a couple of lines of white space between this bit that we want to functionize, as it were, and the rest of the code. So let's do that first.
Response equals int. Response number. We are about to compare the number.
We have this line here isn't super important. I realize it's super small, but given we don't really have visuals anyway, yeah. So I've made a few lines here, as you can see. So let's start here. So we have an if statement here that checks this response is smaller than right guess, and there's going to be a couple of those. So right above where that starts happening, let's start a function. You start a function with the def keyword, short for define. So we will make def
space.
Followed by a spacebar, followed by the name of the function.
C-A-E-C-A. Line. Zoom Q-E-S-S. Left parent. Meeting control. Window. Stop share. Unmute. Currently muted. Alt plus A button. Space. Audio mute. Currently unmuted. Alt plus A button.
How long was I muted?
Just a few seconds. Sorry.
Okay. All good. No good. I was like, I suddenly see this alert that says the host would like you to unmute. And like, wait, how long have I been talking to like thin air? But all good. So what I was saying, we have this this check. Before that, we put a line right above that says def, short for define, and then check underscore guess, and then a parenthesis, and then an open paren. And the paren is where you put your arguments that you're going to need to do the function's work, as it were. So let's actually, just for like teaching's sake, let's give these different names than the ones we would normally have. So we will call these right answer, right underscore answer, and we will call them, let me see what we call them below, response. Now let's call it answer, right answer and answer. And we put a right paren and then a colon, because like we saw last week, you put a colon to make sure your block begins, as it were. In this case, a function is a block. Which make sure that we stay away from the response and the right guess, because we do have access to them in this case, but that's not always the case. So we're just going to make this as like foolproof as it possibly can. Now, I'm going to turn on my full punctuation so you can hear what this actually sounds like as I read the line here. So this is what we currently have.
Check line guess left parent, right line answer, comma, answer right parent, colon.
So now we have right answer and we have answer. Now, the next line is that if statement that we already had. Now, the first thing we're going to need to do is give that an indentation, because right now everything's indented too far to the left. in your IDE, which I'm currently not using, but in Visual Studio Code, you can select these lines and just press tab once and it'll indent all of them. We don't have that luxury right now, so we're doing it old school. We're just pressing spacebar 4 times for every line.
Space. Print left parent, quote your guess is too low, quote right parent, space. Elf left parent, response greater, space. Print left parent, quote your space. Else colon, number, space. Print left parent, quote you space.
There, all
Print
done.
left parent, quote you space, parent
Did
return,
even
space,
did one space too far on this one. That's okay. Now, we have indented everything to the right because this function is now wrapping our if statements that we already had. The second thing we need to do is change the variables we're using from right guess to response to right answer and answer. So in the first line we have if response is less than right guess, that would need to become if answer is less than right answer, because it's a different thing now. There we go. I have changed that. And then we don't use the response in the actual print messages, so that's one less thing we have to worry about. We do need to do this for all 3 of the if statements though, so I'm just quickly doing that as I'm talking. If, well, elif in this case, answer is greater than right answer, we get another message. And then finally, we didn't use any variables here, so that's fine. It just says you got it. So that's essentially done. And now we have our function refactored because this is now contained in its own little thing. There's only one thing we still need to do now to actually make this work, because right now what we've done is we've defined the function. That's what the def keyword is for. But we're not actually calling the function yet. We're not using it in anything. It's just there to be called, to be useful for the programmer. But we haven't actually called it yet. So we're going to do that next. So if I scroll all the way up, I'm going to turn my speech back on so you can hear this.
Speech mode talk. Land.
These are the white spaces, and then we have here.
Response equals int left parent, response right parent, number we are about to compare.
That's that int response that we did right after we, like right before we started hitting enter to make some blank space. Now, what we would need to do here to finish up the loop, as it were, is make this function actually be used. And you do that by just calling it, by saying its name, answer,
left parent.
and then you can do several, we'll do the most simple one at the moment, but you can do several ways to indicate what value is for what particular variable. In this case, we have right answer first and then followed by answer. And if you just follow that same order without doing anything else, you can, without having to do anything else, Python will know what to stick where. And this is one way to do it. You can also give the name of the thing explicitly. This doesn't happen all the time, but does happen. So you could do right answer equals blah and answer equals blah. We're not doing that right now. We're just giving it the, we're just like hoping that the order will work, because in a lot of programming languages other than Python, that's what you'll see more of. And should anyone would like, for example, play with JavaScript, you'll quickly see this a lot as well. So I'll just show it off right now. If we look at our definition, our signature for the function,
Left parent, right line answer, comma, answer right parent, colon.
We see that the first parameter is right answer and the second one is answer, like I said before. So what we need to do is match that order. Now, our particular right answer was right guess up top of the script, so I'll do that as the first parameter.
R-I-A-T, line, G-U-E-S-S, comma.
And then the second one was not answer, but response. So in the slot that we left for the response, for the answer, we're going to put the value that's currently contained in the line we actually did here.
Response equals int left parent, response right parent, number we are about to compare, check line answer.
So now I can do right guess, comma, response.
R-E-S-P-O-N-S-E.
right parenthesis. And these now match up with what we're asking here in def check guess, right answer, comma, answer.
If left parent, answer left right line, answer
And
right
with
parent,
that long-winded
Speech mode
thing, we are essentially done refactoring this bit of the code. This is now a function that we can call from anywhere if we import it. We can import this function from our script, say in another file or another package. And as long as that function is there, we can call that function from our different kinds of code and have this particular this logic check be done on the two values that we stick in there. And with that, our function is done. And I am done speaking. You guys get to ask questions.
Okay, Florian, the first person I believe that had their hand raised was Deborah.
speech mode deep,
Go ahead.
speech mode talk, speech mode off.
Yes, difference between module, package, and framework.
Okay. You actually set them in ascending order, as it were. A module is generally a single thing. A package is something with several modules in it, and a framework is the same thing with several packages in it.
Clear. I'm on mute.
Okay.
I believe the next one in the lineup is Alan.
Yeah, this is just practical stuff. So I'm assuming you're going to post this latest code out there in the notes for this week's lesson.
Oh, absolutely. Yeah.
Are you going to name it something like numbers with module pi, so that for those of us that are saving them on our files,
I'm going to call it numbers refactored.
Okay, and one final question, and this is more this is another cosmetic kind of practical question that has to do with. I know there's a tendency, it seems like, for everybody to use lowercase everything nowadays, and I know historically, just from past programming experience that I've lessons and stuff, historically, like when you have something like right underscore guess, like to separate words with an underscore, so that, I mean, if there's no underscore between them, it to the visually just sighted folks, it looks crazy. So that's how they do it. Is there a tendency for people to start using what I call camel case, where they might capitalize the R in right and then the G in guess and have it all mashed together so you don't have any blanks between it? So I know it's not really here or there, but I'm kind of curious. It seems like I know I use camel case a lot more since I'm doing everything with screen readers now, because it sounds better. It sounds better, and the underscore is not spoken and stuff. So that's
so it really depends on what programming language you use, actually.
Okay.
What you'll find in Python is that they use underscores to separate words. So that's actually why it's referred to as snake case. You use the underscores to separate things. It's a very Python-esque thing. In JavaScript, for example, you'll see camel a lot more.
Okay, well, and I figured it was something like that, so thanks. Okay.
Yeah.
Okay.
If you, for example, go all the way back to Emacs, you'll find a lot of dashes in between words. That's it's very common there. So it's really dependent on what you're using. Go ahead.
All right, Florian, I believe our next person is Avery. Avery, I'm gonna open up your mic.
Yeah, can you hear me?
Yes.
I can hear you just fine. Go for it.
Awesome. So can you define a function within another block, or does it have to be at ended level 0?
This is when you get into classes. And yes, you can absolutely define a function in another block. You wouldn't want to define a function, for example, within an if statement, because that would not work. You'd essentially not always be able to reach it. That's a local scope, as it were. But if you want to stick functions together and like organize them, that's when you get into object-oriented programming in classes, which I will really briefly touch on after we're done with this question round.
Sweet, thank you.
Not a problem.
Florian, there were questions in the chat. I didn't know if you wanted to go through. We've had a couple more hands raised. How would you like to proceed?
Yeah, no, this is some heavy stuff, so I'm cool with taking a bit more time answering questions. Go for it.
Okay, would you like to do the ones in the chat or the right hands, a couple more hands just raised?
We'll do the chats first then.
Okay, Zach asked, quick question. Could I run an if statement within a function which would trigger another function?
Yeah, totally.
I want the user to be asked if they want to play again. And if they type yes, it would trigger the game function. And if no, it would exit.
Yeah, so the way you would organize that is essentially you have a main function. That's like your entry point for your program. And all that main function really does is call the functions in order. Or it could probably even just call the game function, and the game function would in turn call everything else. So at the end of the line, once that function is done running, you could have your main function ask that question and be like, hey, do you want to play again? And then if they say yes, you just run that start game function again. And if they say no, you just exit out. Yes, you can totally do that.
The next question was from Becky. It says, I had a few issues that I am not sure how to figure out how to fix. Response equals int in parentheses, the word response, closing parentheses, is a pinging, is pinging the problem checker in VS Code. How can I fix this? The other one is, you want to do that one first?
That would depend on what the problem is. You can do Control-Shift-M to see what it's complaining about, and then see what it's choking on. This might be very similar to what Deborah was running into. So if you're not on the Discord yet, see if you can get on there, and then I can help you out of class.
Okay. And her second part of her question was, how can I fix this? The other one is else in parentheses print, another open parentheses, and in quote, you got it, closing parentheses. I indented it, but it still is coming up as expected expression silence.
Did you, is there a colon after the word else?
No.
That's your problem.
Manny asked, is it a good practice for a function to always have a return statement, even if it returns nothing?
That is a philosophical question, as it were. It depends on the programming language. In Python, you can usually return either 0 if something is fine, or 1 if something is not fine. That's pretty common in, for example, old Linux programs as well. I do not know what the official stance of the Python developers is on that for Python. I'd have to look that up and get back to you.
Okay, and then we have one hand raised last. Alan has his hand raised again.
Okay, go for it, Alan.
Sorry, that was an accident. I did not mean to do that. Apologies.
All right.
I think we're all caught up, Florian.
Fantastic. All right. So what I aim to do with this particular lecture and the next one is to give you a whole lot of things to get curious about. Like, this is not me teaching you the ins and outs of every single thing you could do in a programming language, because there's a lot of resources out there that can do that way better than I can. But what I do want to do is essentially get your feet wet with a whole bunch of concepts that we can then use to further ourselves, to essentially see, okay, I've learned these things now, what can I actually do with them? And one of the things I wanted to cover today is something that was brought up just now, and that's the concept of what is called object-oriented programming, which is a term you see around everywhere. Like, this was a thing that came out a couple decades ago, and it became this really big thing that people all wanted to sort of be a part of. And then there was this big split where people thought it was awesome or people thought it was absolutely terrible. And I'm in the middle of the middle. It works for the things it works for. And there's different styles of programming that I will not go into right now, because I don't want to do that to you. That's a little bit too theoretical at the moment. But I do want to quickly, briefly touch on object-oriented programming, because it does come up a lot in introductory texts as well. And this is something you will probably need a little bit of time to essentially get to grips with. And that's not because we're screen reader users. That's just because this takes a bit of getting used to. It essentially has a lot of abstractness to it, as it were. Like you need to sort of think a couple of levels higher than what we've been doing so far in terms of the big picture, if that makes sense. And I'm going to explain this in a way that it was explained to me that made a lot of sense to me. So if you don't get this right away, that makes perfect sense. A lot of people don't. It's fine. There is oodles of material about this on the web. You can look up an object-oriented programming guide on Python or JavaScript or anything you'd like, and it'll be explained to you in 12 different ways, and one of them will make sense. Here's my attempt. So once you start seeing that all your functions that you've been making sort of fall into a similar domain, a similar concept, as it were, you might start thinking of how to group them together. That's actually what Avery was asking. Can I put them in like different levels somehow? And this is where classes start becoming a thing, because what a class essentially is a definition for a number of related functions and properties. So just like we just defined a function with the def keyword, you can also define a class, which is essentially a blueprint with a bunch of functions in it that whatever you make with this blueprint needs to be able to do. So if we write up, for example, a class dog, we make a doggo class. What do dogs do? They wag their tails, they bark, they jump, they eat the furniture, and they beg for food and cookies and all the other things. So we would need to essentially define those behaviors from a dog. So if it's a class dog, and that's a block. So actually, if I make I'm actually gonna make a new thing below this, and I will add that to the notes, obviously. But if we were to make a dog, we would make class, the word class, followed by the word dog, and then a colon. And obviously from that point onwards, we started a block. So everything from this point onwards needs to be indented one level, which is generally 4 spaces. So what does a dog generally have? A dog generally has 4 legs. So we can set number _of _legs equals 4. Generally, a dog has a tail. So we could say, for example, has tail equals true. And now we have a couple of behaviors. What do dogs do? So we could say, I'm not going to type this out, but we could make a folder for function dev eat furniture with the argument b table or something. And then we could just have a string, wow. We could then return a print statement that says, nom nom, I just ate your table, or something of that nature. It doesn't really matter. But that would be in that class. So that would be in the blueprint for objects. We don't come what an object is in just a second, but that's in the blueprint for things made with the dog class. And then we can add a bark method and a wag tail method and a jump method and all the other things. A method, and this is a bit of a theoretical difference, but a method is generally a function that's part of a class. Like generally functions and method are kind of used interchangeably a lot of the time, but that's the official definition. So now we have this blueprint of a dog. We don't actually have a dog yet. Remember when I made the function just now, the check guess function, we didn't actually use it yet. It was just there to be used. That's kind of what this is too. Like we've made a class, but it doesn't do anything yet. It's just lying there in like a big filing cabinet that you can use if you want. And then you can set the factories to build these particular objects based on this class. And that's what an object is. An object is what's known as an instance of that particular class. And that really just means that it's a geeky way to say, okay, if I were to take this blueprint and make something with it, that's what this now, like that's what the result of it would be. And that is an object of type dog. And why does that matter? At that point, you can start reasoning about a programming problem in everyday objects. For example, if you're building a web app for, say, e-commerce, like a shopping cart, for example, you could have a class product that has like a title and a price and a quantity. And at that point, you can stick those all in the same sort of structure. And then once you need to list all those things out on the page, you can always be sure that a product has that. It has a name, it has a thing, it has a quantity, it has a price. And at that point, you can write descriptions, like specifications, like a product needs to have a title, a product needs to have this, a product needs to have that. And then you can really easily make an analog from your description of a physical object to the same structure in code. And at that point, you have a really easy way to essentially reason out and think about how you're going to manipulate the objects that your application is going to need. And you see this in, for example, UI development, like a button is an object, checkbox is also an object. But you also see it in, like I say, web apps. For example, maybe a car salesman website will have cars as objects, and a veterinarian's website might have records for the pet they're using, that they are treating. So at that point, you have a way to talk about, reason about, and just describe in regular like words without having to even use code what the code needs to do. Like you don't have to be like, okay, well, this needs to do that. You can actually write up a little story that says, okay, well, my application needs to do the following things. The product needs to have this and this on it. The shopping cart needs to be able to do this and this. And at that point, you can start like looking at relationships between objects, and you can start looking at how we can make these objects as both user-friendly and developer-friendly as possible. And there's a whole lot more to this. Like, I'm not going to cover all of it, but there's a whole lot more to this you can dig into. Should this sound interesting? And this is by far the most common way for programs to be built today. Like this still happens, and this started several decades ago, as I said, and it's still happening today. And that is also the difference between what Deborah said earlier. You can call a method on a thing, and for that you use this dot notation where you say thing dot something. For example, say dog dot eat furniture, paren, table, paren. And at that point, you're calling the eat furniture method on the dog object that you created from the dog class. And I'd say that's 5 times fast. And if you can do that, then you've gotten this lesson down. That is a lot of theory that we just covered. And I think that is enough theory for now on. I will definitely make notes on this that are a little bit more extensive than the ones from last week. Last week, we essentially covered a lot of it already in class, and I commented the file to such a degree that notes were not super necessary. Obviously, in this case, that's a different story.
Speech mode talk. Meeting control.
Now,
speech mode off.
Before I leave, I want to like make it a little bit easier for people to understand how certain things work in regards to like things like Discord and Clubhouse and things. But before I do that, I want to stop one more time for questions if anyone has them.
Okay, we have a couple hands raised, and there was one question that came in earlier. I don't believe you addressed. Hamid asked about whether you would be covering Python networking.
Python networking is not something we'll cover explicitly. However, I will mention resources on what to like look for and learn about in that sense. Like networking, I'm assuming you mean low-level things with sockets, or do you actually mean making web applications? You can answer in chat, have a chance, because web applications is something I will cover a bit more explicitly next week.
Okay, so the first person in the we only have one hand raised. It's Deborah.
Okay, Deborah, go ahead.
Speech mode beeps. Speech mode talk.
I will make sure
Speech
that doesn't overtalk you. Yeah, there you go. Deborah, you're not audible.
Okay, let's try it again. Can you hear me
There you
now?
are. Yes.
Okay, so I noticed your first program had os.run, But most of your other function calls were not calling methods. They were just, function name, left paren, parameter, right paren. So because I don't really need to create objects now, I want to use the ones that are out there. When to dot and when not to dot is my question.
You dot when you import first. So if I, for example, do import OS, which is what I did in that first program, I have the OS module, but it's something I need to explicitly say I want to use something from. So in that sense, the dot can also be used to call methods that are contained in something else. In this sense, it would be os.run because run is part of the OS package that we're importing above. If you want to not do that, what you can also do is from OS import run, at which point you can call it directly and not need to use the OS dot.
I'm fine. I got it.
Perfect.
Okay, there was a question that just came in the chat from Pamela. It says, will you add a list of books that would be good for beginners if we want to dig into the object-oriented end of programming?
Yep, there's already a number of resources on the class website, actually, some of which will definitely cover this once you get up to a certain point. I know that, for example, automate the boring stuff doesn't really. It stays within what's known as procedural programming, which was what we've been doing so far. And that's because in Python, you don't really need to do this a lot of the time. Like if you want to make bigger systems that have objects talking to one another, that's where it's useful. But you're not forced into using objects like you would be in, for example, C#, where that's a bit more common. But yes, I will definitely make sure there's resources on that topic in the list. What I think I'll actually do is I'll gather, because I think there's resources in several of the lesson notes at the moment. I will consolidate those and make like a resources thing at the top of the page so you can just go there directly. Hang tight, I'll get that done in the next couple of days.
Florian, that's all the questions that we have in the chat, and there are no more hands raised at this time.
Fantastic. So I've seen a couple of questions about Discord pop up on the Discord, which is funny. But what I want to do before I go is explain a little bit more. Like I know I covered it in the beginning a little bit, but I want to cover a little bit more about what Discord actually does and what it doesn't do. Because it's a very powerful tool in the right hands, and once you know how it works, it's actually a lot less overwhelming and like odd than it initially seems. It's a bit of a new frontier because it's this whole hybrid web desktop thing that you'll also find in VS Code. But once you get to grips with that, it's actually quite nice. So what I want to do is quickly just explain a couple of things about what it is and what it isn't. Discord is a server-based way to chat with communities. So essentially you have a server which has channels, which has users. So you talk in a channel and everyone who's in that channel can see your messages. People in other channels may not see them unless they're part of the channel you're in. And then only when they're looking at it. So, excuse me. The way it works is you have essentially your list of channels. No, you have your list of servers, your list of channels, and your list of messages in the channel. So there's always going to be these three things on the screen. And that is probably why a lot of people find this a little bit difficult to work with. There's a lot of stuff on the screen, and it helps a lot if you know some of your navigation commands in the screen reader. So going by landmark helps a lot. So like in the NVDA, that's D and Shift D. I forget the key for JAWS right now, but JAWS has a way to do this as well. And that is a really good way because they are labeled pretty well. Like you'll hear here the channel list or the message list or the server list. And at that point, once you've learned that, you can essentially go and zip around the interface quite a bit faster. Another thing you can do is go into, like I said, the focus mode or the virtual cursor off mode, and just tab and shift tab around a bit. You'll find that you can actually arrow up and down through the list of messages, the list of channels, and even the list of servers. This list of servers is a tree view. The other ones are just lists. And you can interact with the message by, like I said before, using the applications key or the Shift F10 key in order to, for example, reply directly to a message. If you do that, the message of the text of the message you're replying to will appear above your message, which is great because then people have context. As for reading messages, there is a way to go to the nearest unread message. I'm not sure if screen readers currently like that way. It's a shift page up, and I think visually it takes you there, but I'm not 100% sure if it does with screen readers yet. It may not, and that is something I will poke them about, because actually in the last couple of years, they've been pretty good about implementing accessibility suggestions up to the degree that you can actually drag things around now with keyboard shortcuts, which didn't used to be possible for a long time. And it's actually something a lot of other applications get wrong. So in that sense, you can see that someone knows what they're doing over there, but also a lot of someone's don't, because sometimes just things break for no reason for a little while, and it's aggravating. But there are quite a few hotkeys that I would recommend looking into. For example, there's hotkeys to flip between unread channels. There's hotkeys to manipulate voice channels, and there's, I'm pretty sure, also a way to flip between like the last text channel and the last voice message channel you were in, which can be super useful for some people. So in that sense, it's quite a good tool for having impromptu discussions, as well as just sort of having a running log of what's being discussed on a server. The voice channels are not something I pay for. Like, you don't have to worry about overusing them or anything of the sort. I don't actually pay for this server. It's something Discord gives us for free. You can pay for like better quality and things like that, but you really don't have to. So if people want to like hang out there and like talk like through their homework, that's absolutely something you can do, even if I'm not there to lead the pack, as it were. And I can make sure that there's more than one voice channel if that's ever becomes necessary. So far, it hasn't really been used much, but it's there for people if they want to use it. If people aren't on the Discord yet and have been put off by H captcha, that is a valid concern, something I'm definitely trying to work on, because I've recently gotten wind that even Freedom Scientific uses this for their JAWS registration portal now. So it would really help if H captcha themselves would fix some of the egregious accessibility issues that they're currently adding to the mix, as it were. But for the moment, we have to deal with it. So it can be dealt with. Like I said in previous class, you just have to do their convoluted 12-step program thing to fix it. But once you're in, and you don't have to do that pretty much again until you like need to re-log in. So if you do log into Discord, make sure you check that remember me box. Otherwise, you have to do the whole thing all over again. Why do I go into this right now? Because there's a lot of applications that follow a very similar format. For example, if you want to do Clubhouse on the computer, you can do that using Club Deck, which is a Electron-based application to deal with the Clubhouse protocol, which actually is a lot more accessible than the phone app these days, because I've been told it's gotten quite a bit worse accessibility-wise. So that is a way to do this on the computer, should you want to. Visual Studio Code has some of these very same aspects where you can use focus mode to get places quicker than you can with browse mode. And so do applications like Skype and Slack. So it's a good idea to get used to essentially this particular way of working with things, because it's here and it's going to stay here for quite some time, I envision. And with that, we are a little bit shorter today, but that's pretty much really all I had to say. So if there's more questions, I'd be happy to answer them. But apart from that, I'm essentially done for today.
This is Ty. Thanks again to CDW for sponsoring today. And if anyone has more questions, feel free to stick around. Thanks, Florian, for everything today. And yeah, I guess you guys are done early a little bit.
So it seems, yeah. We've covered a whole lot of stuff. So yeah, if people want like something to be like explained a little bit more clearly, or detailedly, this is your time to shine.